My name is Will Sikorsky, and I lead the Kaggle competitions team at Google. We love Jupyter for its ability to move between code, data, and visualization. Over 2/3 of the code we write lives in a Jupyter notebook.
Hey, I'm Meg Risdahl, and I lead Kaggle's Notebooks team at Google. Kaggle's community of 5 million data scientists uses our Jupyter-based IDE to learn, participate in machine learning competitions, and explore public datasets.
I'm Carl Weinmeister, and I lead a team of data science advocates at Google. Jupyter Notebooks have been an indispensable tool to help our users learn to build ML solutions in the cloud.
Murega, Jetogo Agwiwa Kariuki, Kuma Master Cohort, Nairobi, Kenya. Karibuni JupyterCon 2020.
Habari zenu, naitwa Mariam Haji kutoka Master Cohort. Karibuni JupyterCon 2020.
What impact does extreme weather have on oil production in the North Sea?
How is a 1 peso tax helping save an entire generation of children?
If 70% of everything we buy is delivered by truck, what happens to your grocery bill when there's a severe driver shortage?
How can bread scarcity spark a global political revolution?
Our planet is alive and interconnected, continually shifting, adapting, and growing.
Every event, big or small, results in other events.
At Bloomberg, you'll investigate, examine, and interpret these unique and seemingly unrelated connection points in real time.
The success of our business relies on people just like you,
who can look into the future and create groundbreaking technology, research,
and expert insight to answer the world's most complex questions.
When we solve problems with a greater sense of purpose,
change begins.
Dots connect.
Society excels.
The world transforms when work has meaning. Your career thrives when you feel a deep connection to it.
That's why at Bloomberg, we work on purpose.
Ready to find yours?
Hi JupyterCon, this is Jan from PyData Südwest.
Guten Tag, this is Alex, and this is how Südwest looks like. And this is how you can find us.
Yes, exactly. So we are a region of highly interconnected cities, and we decided to join forces and host a multi-city meetup here in this area. And as you can see, we're not too far from the French border or the Swiss border, but actually it's really easy to get here from anywhere really. Even by train, it's quite easy.
Our PyData community is as any other PyData community, all about community and of course data and programming. Unfortunately, we couldn't get hold of everybody, but here are some members of our community who would like to say hello and introduce themselves.
Hi everyone, it's Christina. I'm one of the organizers and I'm from Mannheim.
Hey, this is Larissa. I'm a data scientist at Savanta from Heidelberg.
Hi everyone, this is Sia from Heidelberg.
Hey, this is Kiran. I'm a data scientist from Heidelberg.
Hi, I'm Matthias from Baden-Baden, new member from PyData Südwest.
Hi, I'm Kevin from Karlsruhe, currently in Austria.
Hi, I'm Uwe. I'm a data engineer and a PyData organizer from Karlsruhe.
Hi there, this is Ingo from Karlsruhe.
Hello, this is Xia Tong. I'm a data analyst from Heidelberg.
So over the last 2 years, we actually hosted a bunch of really cool meetups in this area with topics ranging from Python for astronomy to building dashboards with Jupyter. And we're really proud to say that we had both local as well as international speakers as guests in Südwest.
So, if you are from our region and you are not a member yet, please come and join us. If you travel by, come and be our guest. You are always welcome. We would also like to thank the organizers of JupyterCon for organizing the conference and giving us the opportunity to present ourselves here. Viel Spaß!
Enjoy!
Enjoy JupyterCon!
Enjoy JupyterCon!
Enjoy JupyterCon!
Enjoy JupyterCon. Thanks.
Enjoy JupyterCon!
Enjoy JupyterCon.
My name is Will Sikorsky, and I lead the Kaggle competitions team at Google. We love Jupyter for its ability to move between code, data, and visualization. Over 2/3 of the code we write lives in a Jupyter notebook.
Hey, I'm Meg Risdahl, and I lead Kaggle's Notebooks team at Google. Kaggle's community of 5 million data scientists uses our Jupyter-based IDE to learn, participate in machine learning competitions, and explore public datasets.
I'm Carl Weinmeister, and I lead a team of data science advocates at Google. Jupyter Notebooks have been an indispensable tool to help our users learn to build ML solutions in the cloud.
Murega, Jetogo Wagui wa Kariuki, Kuma Master Cohort, Nairobi, Kenya. Karibuni JupyterCon 2020.
Habari zenu, naitwa Mariam Haji kutoka Master Cohort. Karibuni JupyterCon 2020.
What impact does extreme weather have on oil production in the North Sea?
How is a 1 peso tax helping save an entire generation of children?
If 70% of everything we buy is delivered by truck, what happens to your grocery bill when there's a severe driver shortage?
How can bread scarcity spark a global political revolution?
Our planet is alive and interconnected, continually shifting, adapting, and growing.
Every event, big or small, results in other events.
At Bloomberg, you'll investigate, examine, and interpret these unique and seemingly unrelated connection points in real time.
The success of our business relies on people just like you.
Who can look into the future and create groundbreaking technology, research,
and expert insight to answer the world's most complex questions.
When we solve problems with a greater sense of purpose,
change begins.
Dots connect.
Society excels.
The world transforms when work has meaning. Your career thrives when you feel a deep connection to it.
That's why at Bloomberg, we work on purpose.
Ready to find yours?
Hi JupyterCon, this is Jan from PyData Südwest.
Guten Tag, this is Alex, and this is how Südwest looks like. And this is how you can find us.
Yes, exactly. So we are a region of highly interconnected cities, and we decided to join forces and host a multi-city meetup here in this area. And as you can see, we're not too far from the French border or the Swiss border, but actually it's really easy to get here from anywhere really. Even by train, it's quite easy.
Our PyData community is as any other PyData community, all about community and of course data and programming. Unfortunately, we couldn't get hold of everybody, but here are some members of our community who would like to say hello and introduce themselves.
Hi everyone, it's Christina. I'm one of the organizers and I'm from Mannheim.
Hey, this is Larissa. I'm a data scientist at Savanta from Heidelberg.
Hi everyone, this is Sia from Heidelberg.
Hey, this is Kiran. I'm a data scientist from Heidelberg.
Hi, I'm Matthias from Baden-Baden, new member from PyData Südwest.
Hi, I'm Kevin from Karlsruhe, currently in Austria.
Hi, I'm Uwe. I'm a data engineer and a PyData organizer from Karlsruhe.
Hi there, this is Ingo from Karlsruhe.
Hello, this is Xia Tong. I'm a data analyst from Heidelberg.
So over the last 2 years, we actually hosted a bunch of really cool meetups in this area with topics ranging from Python for astronomy to building dashboards with Jupyter. And we're really proud to say that we had both local as well as international speakers as guests in Südwest.
So, if you are from our region and you are not a member yet, please come and join us. If you travel by, come and be our guest. You are always welcome. We would also like to thank the organizers of JupyterCon for organizing the conference and giving us the opportunity to present ourselves here. Viel Spaß!
Enjoy!
Enjoy JupyterCon!
Enjoy JupyterCon!
Hi everyone, my name's John Bannister. I work at Man Group, and today I'm going to talk to you a little bit about how we've created a process which takes our Jupyter notebooks from research into production. So just a little bit about myself first. My name is John Bannister. I'm a senior engineer within the Man Data Science group, where mostly we onboard data and draw analyses out. And as part of that function, we use Jupyter notebooks quite a lot to encapsulate the research that the analysts are doing and also to share that. So one of the main problems that we have is that there's no real easy way to share a lot of the insights and make them reproducible. So on that, I also am lead of the Man Group Architecture Committee for Notebooks. And on that, we work to ensure that we're at the bleeding edge of the Jupyter ecosystem. So that means we look at new packages that are coming out. We determine which is best to use, Lab, Hub, Notebook. And we, as part of that, we've created a tool called Notebooker, which will allow users to take their research from their computer into production really quickly. I'm also available on GitHub if you're interested, and that is also where you'll find my contributions to the Notebooker project. So this is a very common statement that we get from the researchers at Man Group, who say, hey, they've done some research. We work at an investment manager, so it's important that they have very good insights and they know exactly how to share these insights with other quants, other researchers internally. So they usually want some insights that they've created and they want to take them out and they want to reproduce them every day, for example. So they'll ask a developer like myself, so how do I get these insights out and how do I, can you do this for me, basically? And the answer is, we don't really have much time to do that. And so, this makes people sad, and it's quite an inefficient way to operate, because the research has already been done and the code's already there. We don't really need to rewrite it. We just kind of need to empower the researchers. So why don't we let the users themselves do the publishing and turn their notebooks into a kind of production quality report? So what's required for that? I mean, Jupyter notebooks are great, but they're not really production tools usually. They're for research and for playing around, and they're brilliant, but they're not technically really for production usage. And so there are a lot of features missing, namely reviewability. How do you review a Jupyter notebook? Templating. How do you take one Jupyter notebook and produce others with that? And that falls under parameterization as well. If I want to run a report for every single stock in the Dow Jones, how will I do that? Would I have to write 50 different reports, 50 different notebooks? Ease of use, so making sure that non-technical users can actually, contribute to the ecosystem. Scheduling, so say I've written a report and I want it to be run every day. How do I ensure that, and is that as easy as possible? Publishing, sending in a .ipy notebook file isn't a great way to share your insights, so is there a better way we can do that? And finally, testing to make sure that this is actually of a production quality, and making sure that it's useful going forward and it won't break. So let me just talk first a little bit about what we've done internally, and then hopefully that'll give you some insights as to what you can take away and do in your own businesses or wherever, and give you a little bit of insight as to what we've done. So Notebook is a project that's been running since 2018. It was, I think, JupyterCon in Cardiff 2018 that gave us some of the ideas, where we heard about Jupytext, which I'll go into some detail on later, and Papermill, which is another really useful library that I'll also talk about a little bit later. And how do we combine those two, and maybe we can turn this into a project which really empowers users to publish their own work. So this is what we've done. We've written a little web app around notebooks in general. So each line on this table here shows you results. So it's a successful report that's run. It's a Jupyter notebook that's been executed, basically. And it shows you a bit of metadata. It allows you to rerun it. And if it's gone completely wrong, it shows you how to delete it as well. This is what the results look like. So we've stripped away all the code from the results. You can toggle it if you really want. But it really shows the kind of more interesting stuff that people really want to see. So it's all in HTML. And also we've got the option to generate PDFs as well using NB-convert. So that means that, in fact, you can output as you like. You can do a report and it will turn out like it's been done by a developer. So the difference between what a developer would produce and what a researcher can produce with the framework is kind of not very different. So this is a really powerful tool. A little overview of how it works. So there are two ways to run a notebook or report. So either you ask a scheduler like Jenkins or Cron or Airflow. You say, okay, I want to run this. Likewise, you can do exactly the same through the web app. So you run a template. You also give it some parameters that you add on top of the template. And then Jupytext converts your template into an IPy notebook, and then it can be executed by Papermill with the parameters added on top. Then when it's done, we save the results into a Mongo database, and we publish the results to email if you choose to. So it's available on GitHub now, so check it out, have a look, give it a star if it's a project that's useful to you. And yeah, feedback and pull requests are very welcome. So the solutions, so the things that we've addressed with Notebook are this is probably much more applicable to you guys. Notebook is a useful tool, but there may be some concepts here that will be useful more generally. So you don't have to pick up Notebook yourselves. You can just left out little bits that are cool. So firstly, taking a notebook and using it as a template. So there's loads of code in a notebook. In our example, we are a pure Python shop, pretty much. So we're using Jupyter notebooks with Python. We strip out all of the results, so all of the graphs, all of the standard outs. We turn it into code, and we reuse that code to generate a new Jupyter notebook. And with that, we can execute it and then store the results in the database. We use a tool called Jupyter, which I mentioned earlier. It's a really, really useful tool. I suggest you check it out. It's available on GitHub. I actually think he's doing a talk in this conference as well. So shout out to Mr. Woots, you're a legend. This is a really useful utility which allows you to interchangeably convert between an IPy notebook and the underlying code or markdown or whatever you like, and back. So it basically can sync your code file with the actual Jupyter notebook file, which is really useful for what we're trying to do here. It also means that we can review things a lot more easily. So I don't know if you've used a Jupyter notebook in the past in GitHub and tried to look at the diff, but an IPy notebook is a massive blob of JSON. It's really difficult to review, especially when picking apart what's happened. Especially with like an image change, it's just a blob of hex. So you're not really going to understand what's happened there. So there are existing tools to deal with that. So GitHub has some integration. I know there's a tool called MBDime, but by stripping out all of that, we've actually solved the problem by just converting to a Python file, which is, as it is, it's very easy to review because it's just a few lines rather than a very, very large file. So when you commit to Git, your template will appear on the web app automatically. So the web app, as soon as you make a request, it will go off to Git and check whether anything's changed in master. If it has, it pulls in. And therefore it refreshes as soon as you push to master. Then it renders your template on the execution screen. So on the right there, you can see the highlighted cell, which is the parameters cell. And then you can see on the left how you're going to override that, what you're going to override that with, and you can actually write pure Python in that text box, which means it's not super secure, but that's not a massive concern for us internally because who's going to run it? And we've got security layers on top of security layers, so it's very unlikely that an untrusted party is going to run this, which means we can do interesting and cool things like executing Python on a web app. And also you can see there's an option here to email to yourself, have a custom title, and things that are generally useful for life admin, as it were. So something that I alluded to here, if you look in that cell that's yellow highlighted, those are the parameters. So how do we specify those parameters? And we want to override those parameters ideally. So if we've got a template, we really want to add some parameterization. So in our example here, we've got a toy example where we want to run a version of a report for every color of the rainbow. So here what we're going to do is add a color parameter to the template. So color is red in this case. And then we run the report multiple times, once per color. So instead of having to write 7 different notebooks or reports, we just write one and we add a template for the color, a parameter for the color rather. So to add these parameters, we use cell tags, which is a kind of not very commonly used feature in Jupyter Notebooks. In fact, it was only very recently added to Jupyter Lab, the supports. Otherwise, you had to use cell tab extensions, I think it's called. So it's not a very commonly used feature, but it's really useful for our use case because we can specify here this cell is something that we want to be able to override. And then what we do is we use Papermill, which I mentioned earlier, which can execute the notebook with these parameters added, which is awesome because that means that we can then take our templates and suddenly we just write 7 cron jobs or 7 Jenkins jobs or whatever to execute the reports and get the results that we need. So in terms of ease of use, I mentioned earlier that we auto pull from Git. Internally at Man Group, everything is using Git. We have quite technical researchers, and so the kind of common sense thing to do was, let's just use Git for everything. And so when we deploy our notebooks, it's literally just as simple as committing to Git, which means that from a user's standpoint, all you need to do is take your Jupyter notebook, convert it into Python, which is automatically done by Jupyter text, and then commit that Python file. Once it's merged into master, great, you've got a report in production. Wonderful. So let's follow through an example of our rainbow. So here we've got the Jupyter template. So we've converted from IPyNotebook into Python file using Jupytext. So here's what it looks like. That's the output of Jupytext. It's pretty stripped down. You can pretty easily understand what's going on there. A bit of metadata at the top, which is useful for Jupytext and also for executing with PaperMill. Then we've merged to master, so it appears in the UI, which is great. So we go to examples rainbow, and then we see here that our highlighted cell is the parameter cell, which is perfect. We add, if you can see on the right there, it says color equals yellow. So we've added our parameter, and the report has started running with a cute little animation, which you can't see here, sadly. And you get all the standard out, so you can see exactly what's going on. And then finally you get your results here, and you get this kind of disgusting yellow report, which is not very pleasant to look at, but that's what we wanted. So what I've shown you here is that you can basically add in any parameter you like, and you can override it very easily using Notebooker, and then suddenly your results are shareable. So here you've got a unique URL at the top of the page, which will send you to this result and this result only. And it's all stored in Mongo, so it can be retrieved very easily later. And an example of the PDF generation, this is what it looks like. A future enhancement that we kind of want to add is that ideally we remove the code from the PDF, but for now this is what it looks like. So some people find this very useful, especially researchers who want to send it to clients, for example. So in terms of scheduling, once we've got a template and we like it, usually what we want to do is see what it looks like every day or every week. So in terms of deployment, there are a couple of options here, but what we really want to do is make sure that we're running in a convenient and a consistent way. So Docker is a really good choice here because that allows us to have a very consistent workspace, and to make sure that our requirements are all in place, we in the notebook templates repository that you're committing in Git to, you have a notebook requirements.txt, which means that you add in all of the package requirements that you have, so like pandas, numpy, whatever. So PaperMill allows us to execute these templates, and we give it the kernel to use, which means that when we build the kernel in the Docker image, it's there forever because it's a Docker image. And then with our new Jupyter notebooks, we can just execute with exactly the same environments. The only time we need to rebuild the Docker image is when we add new requirements into the notebook requirements.txt. The backend, which actually executes these reports, is exactly the same. So we've obviously done a wrapper around PaperMill where we save the results into Mongo afterwards. But that uses exactly the same backend for both the command line and for the web app itself. So we've ensured that the code is the same, you're running the same thing, and it means that it's just a bit more consistent as well. You can call the command line from any schedule you like, so Airflow, Kubernetes, Jenkins, cron, whatever. And because everything's stored in MongoDB, it's easily browsable afterwards. So publishing and sharing. So there's some features here which were added by internal contributors. So we have a pretty big internal open source community, if that makes sense, where people are allowed to kind of spend 10% of their time on whatever they like. So there's a small team dedicated to working with notebooks and Notebooker, and people come in and contribute things. And one of the things that was contributed was the ability to search. For example, if we take my rainbow example earlier, where I ran for the color blue, I want to find the latest report that was successful as of a given date, because I think that something changed with the color blue a month ago. So you can do that because we're using a Mongo database, which means we can search for parameters, and it's very easy to just retrieve from a query of your choice. So we've added a bunch of helpful URLs to the web app itself to do this searching for you, but because we're storing in a database, you can just go and do an ad hoc search for yourself as well, which is great. We store everything, and therefore we browse everything within one instance. And so teams within the company have set up their own instances of Notebooker. So they've got a kind of team-specific instance, which can be locked down if you want. So, for example, we've got a portfolio management team internally, and they've completely locked it down. So only that team can view that instance. And so everything is kind of confined to one instance, but that means that the URLs that you're generating are very much pointed at that one thing. So that's very useful. And finally, so we really want to check that once we've deployed these reports, we want to keep them running. It would be pretty bad if we set something up to run one day and then it completely flopped over in 3 days' time. So actually a really nice thing about using Jupyter to convert to Python, and keeping everything in Python in the GitHub repository of templates means that we can just use PyTest. We can execute the files from start to finish, make sure it's running fine. People can add custom tests, so they assert that something has happened at the end of their notebook. But mostly, as a framework, what we've decided to do is make sure that so finally, testing. So in the use case where you've deployed something that you want to run once a day, and in 3 days' time it falls over, that's not great. So definitely in production, but in this case where we're trying to treat Jupyter notebooks like their production reports, it's extra, the sort of extra concern that we want to make sure that stuff is still running and executable. So the great thing about using the Jupyter library means that our IPy notebooks are now Python files, and they're stored in Python in Git. And that means that we can just run PyTest. We can make sure that all of these Python files are executing as we hope them to, and then assert that certain things have happened afterwards. So make sure that we've saved to the database and it's success. It is a success. Things like that. So that's really nice. But a caveat of this is that your notebook shouldn't really do anything outside of the notebook experience. So, for example, your notebook shouldn't go off and write to a database. That would be pretty bad if you're running that in a unit test. So we allow people to opt out of regression testing for their notebook instances. But we've created the functionality for people to use it there, and therefore just execute your notebooks and see how they go. There are tools out there for IPy notebooks in general, for you to test and make assertions within a Jupyter notebook. But in this case, we're just converting to Python, so we just use PyTest. So some final thoughts. Notebooks as reports have kind of actually been a surprising success. I really only created them in the notebook, in the data science team, just for my own pleasure, really. I had some reports that I had to run. I didn't really want to write a reporting framework, and I figured, I can write this in a Jupyter notebook and publish that notebook. It's now being used by more than 20 teams across the whole business. So it's being used for a massive gamut of all use cases you can imagine. But it can be anything from Jira reporting, sprints, data quality, production monitoring, portfolio management, anything really. So it's obviously useful. I really hope that it's been a useful and insightful talk for you guys. Maybe giving you some ideas as well for yourselves on what to take away for your own businesses and what's going on there. So in conclusion, have a look at the Notebooker project. It's a silly name, I know, but it's got a place in my heart. It's a really useful tool, and do join the community, raise some issues. Pull requests are absolutely welcome. Give us a star, and thank you very much for listening. Here's some legal stuff, which has been put here by compliance. So read that if you really want.
My name is Will Sikorsky, and I lead the Kaggle competitions team at Google. We love Jupyter for its ability to move between code, data, and visualization. Over 2/3 of the code we write lives in a Jupyter notebook.
Hey, I'm Meg Risdahl, and I lead Kaggle's Notebooks team at Google. Kaggle's community of 5 million data scientists uses our Jupyter-based IDE to learn, participate in machine learning competitions, and explore public datasets.
I'm Carl Weinmeister, and I lead a team of data science advocates at Google. Jupyter Notebooks have been an indispensable tool to help our users learn to build ML solutions in the cloud.
Murega, njĩtagwo Wangui wa Kariuki, Kuma Master Cohort, Nairobi, Kenya. Karibuni JupyterCon 2020.
Habari zenu, naitwa Mariam Haji kutoka Master Cohort. Karibuni JupyterCon 2020.
What impact does extreme weather have on oil production in the North Sea?
How is a 1 peso tax helping save an entire generation of children?
If 70% of everything we buy is delivered by truck, what happens to your grocery bill when there's a severe driver shortage?
How can bread scarcity spark a global political revolution?
Our planet is alive and interconnected, continually shifting, adapting, and growing.
Every event, big or small, results in other events.
At Bloomberg, you'll investigate, examine, and interpret these unique and seemingly unrelated connection points in real time.
The success of our business relies on people just like you.
You can look into the future and create groundbreaking technology, research,
and expert insight to answer the world's most complex questions.
When we solve problems with a greater sense of purpose,
change begins.
Dots connect.
Society excels.
The world transforms when work has meaning. Your career thrives when you feel a deep connection to it.
That's why at Bloomberg, we work on purpose.
Ready to find yours?
Hi JupyterCon, this is Jan from PyData Südwest.
Guten Tag, this is Alex, and this is how Südwest looks like. And this is how you can find us.
Yes, exactly. So we are a region of highly interconnected cities, and we decided to join forces and host a multi-city meetup here in this area. And as you can see, we're not too far from the French border or the Swiss border, but actually it's really easy to get here from anywhere really. Even by train, it's quite easy.
Our PyData community is as any other PyData community, all about community and of course data and programming. Unfortunately, we couldn't get hold of everybody, but here are some members of our community who would like to say hello and introduce themselves.
Hi everyone, it's Christina. I'm one of the organizers and I'm from Mannheim.
Hey, this is Larissa. I'm a data scientist at Savanta from Heidelberg.
Hi everyone, this is Sia from Heidelberg.
Hey, this is Kiran. I'm a data scientist.
Hello everyone, welcome to Notebook Ops, a pattern for building notebook-centric data platforms. Perhaps a better title would be How to Build a DIY Analytics Platform Using Open Source Tools. Today, I'll talk about my experience from helping set up such a platform at Grofers, which is one of India's largest grocery delivery services. A little bit about me, I'm Vinayak, a software engineer currently living in New Delhi. I maintain Camelot and Excalibur, two tools that can help you extract tables from PDFs. You can check them out at this link. Right now, I'm in the Fall 1 batch at the Recurse Center, which is a self-directed educational retreat for programmers in New York City. At RC, I'm working towards becoming a better programmer. Back to the talk. For the past few years, we've been seeing this growing trend of enterprise notebook infra. It has been a recurring theme at every JupyterCon, including this one. Every data engineer that I've talked to has worked on or is working on setting up some kind of a notebook infra at their organization. This quote from Brian Granger sums it up pretty nicely. He says that we are entering an era where large complex organizations need to scale interactive computing with data to their entire organization in a manner that is collaborative, secure, and human-centered. He further adds that there is an organizational shift from the historical usage patterns of Jupyter being used by individuals in an ad hoc manner to the new world of large-scale Jupyter deployments. At JupyterCon 2018, Paco Nathan also pointed out how large organizations are adopting Jupyter at scale. He says that on the one hand, there are people in the organization who are well-trained in the problem, the domain experts. They may not have the technical expertise at first, but they can use Jupyter to gain enough of the tooling to really amplify what they're doing in the domain. This is also called citizen data science, where enterprise notebook infra makes it easy for anyone in the organization to get access to data and do wonderful things with it. Also, on the other hand, there is the fresh graduates that these organizations are hiring. And since they already know how to use Jupyter because of their coursework, enterprise notebook infra can help them deliver results from the first day itself. Over the past few years, we have seen multiple talks and blog posts from large organizations like PayPal and Civis Analytics around this theme. But perhaps the most famous of all stories is of Netflix, where they've set up a DIY data analytics platform by putting notebooks at the core. In their platform, anyone can launch a notebook server on demand. Users can also choose resources like CPU and memory, after which their server gets launched in a container using Titus, which is their container management platform. And if someone wants to schedule their notebook to run at specific times, they can do so using Meson, which is their internal workflow orchestration platform. In a notebook-centric data platform, everything is a notebook. You want to write an ETL? Notebook. You want to train a model? Notebook. You want to send out a daily report? Believe it or not, notebook. Let's go back to 2019. In February, I joined Grofers as a data engineer in the Bangalore team. This is what the data team looked like. We had around 15 data analysts and around 5 data scientists. And the data team was supported by 3 data engineers, including me. Everyone in the data team was using Jupyter Lab. By that, I mean that we had one large EC2 instance set up, which was running Jupyter Lab and serving everyone. When something didn't work on this big instance, they would move to using Jupyter Lab on their laptops. Read credentials for various databases were often seen hard-coded inside notebooks, from where they would eventually land up in GitHub. And when someone in the data team wanted to schedule their notebook to run at a specific time, one of the engineers would use NB-convert to turn the notebook into a Python file and then schedule it as a cron job on the same EC2 instance. These could be notebooks that do ETLs or send out reports every morning. We also had an Airflow instance running on another EC2 for when someone in the data team wanted to run complex workflows, where they wanted some dependencies between tasks. Let's discuss some of the problems in this whole setup. With one Jupyter Lab serving many users, there was no concept of a user session. One person's large workload could disrupt other users on the same system. This led to the other user moving to a Jupyter Lab on their laptop, which meant that they had to figure out a way to transfer their work from the server to their laptop. When one user upgraded a Python package on the server, the package would get upgraded for everyone, which would sometimes break another user's workflow. It was also a pain to keep the dependencies on the Jupyter Lab and Airflow instances in sync. And because of the dependency mismatches and a user constantly moving their work between the server and their laptop, it created a works on my machine problem. This also made it hard for another person to build on past work, because even if they were able to somehow find an old notebook, they wouldn't know the dependencies required to run it. And when someone in the data team wanted to schedule complex workflows, they wouldn't be able to do that themselves unless they were familiar with Airflow's Python API. This added a dependency on a data engineer to translate their notebook's core logic into Airflow. Over time, this approach put a lot of maintenance burden on the data engineers. This also added another dependency for when someone in the data team needed to debug why their workflow was failing on Airflow. Over time, Grofers has built a DIY data DevOps culture where anyone can provision new infra resources and create Jenkins jobs very easily. There are dedicated infra and CI teams that have set up awesome tooling for this. Around the time we were facing the problems I just mentioned, the infra team set up a Kubernetes cluster, and there was an org-wide move to migrate services to Kubernetes. Anyone could install anything on the cluster once they had set up the required tooling. During that time, we in the Bangalore data engineering team started to think about how we could solve all the problems the data team was facing, using the infra and CI tools that we had at our disposal. These are Deepu and Sangarshan and my awesome teammates, and going forward, I'm going to be talking about all of our collective work. We knew about the notebook-centric platform Netflix set up from all the blog posts and talks they put out in 2018, so we had a general idea of what the state of the art looked like. But since some of the things in there weren't open source, we started looking for alternatives. And we found these tools, some of which we were already using. We decided to use Kubernetes in place of Titus for container management, Jupyter Hub in place of Interact as a multi-user notebook environment, and Airflow in place of Meson for workflow management, with some GitHub and Jenkins automation as glue to tie the Jupyter Hub and Airflow instances together. Let's talk about each of these components in some detail. Jupyter Hub is an awesome multi-user version of Jupyter Lab, which is designed for large user groups. The Jupyter team has written great docs on how you can set up Jupyter Hub on Kubernetes, where each user can spin up their own Jupyter Lab environment in an isolated Kubernetes pod. Jupyter Hub is famously used to serve more than 1,000 students in the Foundations of Data Science course at UC Berkeley. If you already have a Kubernetes cluster, it is pretty easy to set up Jupyter Hub using Helm. You just need to create a config in which you declare all of the settings that you need. For example, you can configure how someone logs into Jupyter Hub with a bunch of different methods. We used Google Auth, which meant that everyone with a grofers.com ID could access the whole platform using Jupyter Hub. And we used AWS's EFS to store everyone's files. Using EFS, every user would get a brand new file system which would be mounted on their Jupyter Lab server at /home/jovial. Anything that they created would be persisted on EFS at home/their username, and whenever they shut down their server and launched it again, the same EFS path would be mounted again. If you are wondering who Jovian is, it's just the name of the default user that shows up in Jupyter Docker images. In science fiction, a Jovian is an inhabitant of planet Jupyter, and in reality, it refers to Jupyter users like ourselves. You can reuse a bunch of Docker images that the Jupyter team maintains to create different environments for your users. For example, you can use a data science notebook Docker image, which contains all of the commonly used data science libraries, and create a new image out of it. You just need to import it at the top of your Docker file and then add commands to install all of your own libraries. We also did that and pushed the built images to our Docker registry. And after you built on top of an existing Docker image and pushed it to some registry, you can just list that image as one of the profiles in your config. All of the pre-built images that you list in the config show up like this when someone is looking to launch a server. You can also modify the existing form template to let users select the CPU and memory for their environment. And when the user clicks on start, they get their own Jupyter Lab running in an isolated Kubernetes spot. These environments remain the same across all users, which ensures reproducibility in the work that they do. For users logging in for the first time, we added a README notebook where they could give in some details like their name and email, and execute cells one by one to get SSH and GPG keys, which they could then add to their GitHub account. This made sure that they were able to clone and create repos inside the main org account, and also made sure that all of their commits were verified. We also built an internal Python library which automated some common tasks that everyone would do, and then added it to all the environments. One of these tasks was getting connections to databases within the org. So we added a function called getConnection, where any user could just pass in a simple connection ID to a database, get a connection, and make a query on the database. All IDs were listed in the README from earlier, and this solved the problem of hard-coded credentials inside notebooks being pushed to GitHub. The library also had other functions for some other common tasks, like sending emails, storing and retrieving files from S3, and creating tables in our data warehouse. All of this was adopted very quickly, as that was much simpler than everyone's earlier workflow. Let's talk about culling. Jupyter Hub has this nice feature where it can terminate or cull inactive user pods. This helps to scale everything down when resources aren't in use. You can set an inactivity time period after which a pod should be terminated. We found that this feature would cull user pods even if they left Jupyter Lab open in a browser and context switched to another task. This would usually happen when they were running a big task like training a model or running a large query. And it was painful for them when they came back and saw that the long-running task didn't complete because their server was no longer there. To overcome this, we used another Jupyter Hub feature called named servers, where you can launch a server and also give it a nickname. We modified the culling behavior to ignore pods that were launched with the LLAP suffix in the nickname, where LLAP stands for live long and prosper. And whenever we released a new version of the toolbox library, we built all the Docker images again, pushed the new images to our registry, and upgraded the Jupyter Hub deployment on Kubernetes. That made sure that everyone got the latest goodies when they launched a new server. And this did not affect users with running servers. They would just get the new environment when they relaunched their servers. Now that we had ensured a consistent and reproducible experience with Jupyter Hub, the next question was, how do we replicate the same experience for scheduling notebooks while also making the scheduling process very easy? At this point, we still had Airflow running on an EC2 instance, but the data team had grown and there were more users on the platform who wanted to schedule notebooks. That amplified some of the problems we saw earlier, and it started becoming difficult to scale and maintain Airflow on one EC2 instance, with the additional dependency on authoring and debugging workflows. Before we go further, let's briefly look into what Airflow is. Airflow is a platform where you can create and monitor workflows. You can think of it as a powerful cron. It has a simple Python API that lets you define workflows as DAGs, or directed acyclic graphs. It also comes with a lot of operators that let you define individual tasks inside your workflow. Let's see how we can define a DAG in Airflow. So each tag is a Python file where you import the DAG class and instantiate a DAG object with some metadata about the DAG, like the DAG ID, the owner, the date from which it should start running, and how often it should run. You can then import one of the bazillion operators. Here we import the Python operator, which lets you create a task to run any Python function. We then instantiate some task objects with this operator, and as you can see, each task is an ID, the Python function that it should run, and the DAG to which it belongs. And finally, we can define the dependency between tasks like this. Airflow comes with a nice web interface where we can see what the DAG looks like. This interface also shows you all the times the DAG is run, the status of each run, and the status of each task in that run. You can also click on individual tasks to view all of their logs. There's also a DAGs view where you can see a high-level status of all the DAGs running on your Airflow instance. Airflow also has a concept of executors which define how and where your task will be executed. You can execute tasks using Dask or Celery, and also configure the executors to run on a single server or in a distributed setup. Around the time we were working on solving some of the problems I mentioned earlier, we heard about the Kubernetes executor, which was shiny and brand new at that point. It can let you run each of the tasks in your DAG in their own Kubernetes pod. And to do that, you just need to define an executor config inside your Python DAG file with the Docker image that you want your task to run with. You can also define some Kubernetes specific things like the CPU and memory resources for the task pod. And after that, you can just add that executor config to your tasks like this. And just with this small change, all your DAGs become Kubernetes compatible, where each task in the DAG runs in its own Kubernetes pod. But how does Python operator relate to notebooks? Let's get back from the Airflow digression. And let's look at Papermill, which is an awesome Interact project built for configurable and reliable execution of notebooks. It lets you execute your notebook and save the output in another notebook, which can either go to S3 or any other object storage. You can also add a parameter stack to a cell and configure Papermill to inject inputs at runtime. Papermill just tags another cell after this tagged cell, thus overriding the variables in the earlier cell. This is super powerful for running notebooks in production. Last year, Airflow also added support for the Papermill operator, which means that combined with the Kubernetes executor, you can execute your notebooks in a Kubernetes pod using Papermill and then save the output notebook to S3. Airflow also has this powerful concept of macros, which can become input parameters to Papermill in the Papermill operator itself. For example, you can create a nice file hierarchy for output notebooks on S3 by specifying the DAG and run IDs in the Papermill output path. And if you're doing something like incremental loads in your notebook to backfill data into a sync table, you can specify the start and end date for your source SQL query as Airflow macros, which Airflow will pass to Papermill at runtime based on the date on which the DAG runs. Finally, you get a notebook DAG, which executes the notebook in a Kubernetes pod using Papermill with the image and resource requirements you provided, and then saves the output notebook to S3. We also configured Airflow to send alerts on Slack whenever a notebook failed. The alert would tag the DAG owner and also have a URL for the output notebook on commuter. And once a day in the morning, we would also send an automated email to every DAG owner with a short summary of the notebook run stats for the past day. And like I just mentioned, we set up Commuter, another awesome Interact project, on the S3 bucket where we were saving the output notebooks from Airflow. This was really helpful to look at notebooks when they failed. Airflow also shows you the logs on why a notebook failed, but the Commuter UI, where someone can look at the full output notebook and go to the cell that failed to look at the exact error, is a much nicer experience than looking at large logs on Airflow. One thing that you might want to think about with the Kubernetes executor is how you deliver DAGs to your DAGs folder, which is where all the Python DAG files are kept. On one server, all Airflow components can see the DAGs folder because they share the same file system. But in a distributed setup like Kubernetes, there are 3 ways you can go about it. 1, have a sidecar container in all the Airflow pods that regularly pulls new DAGs from a Git repo. 2, build the DAGs into the Airflow Docker image itself, which can then be reused across all Airflow pods. Or 3, have a way to push new DAGs to a network file system, which can be mounted on all Airflow pods. We had a GitHub repo where we maintained all our DAGs, but we went with a third way because we already had a network file system, EFS, that we were using for Jupyter Hub. We didn't go the second way as we didn't want to build a new Airflow Docker image every time someone added a DAG, since that was happening quite often. And like Jupyter Hub, you can install Airflow on your Kubernetes cluster with Helm. This command uses the Airflow Helm chart from the stable Helm repo, but the Airflow community is soon coming up with their own official Helm chart, so you can keep a lookout for that. So with the Kubernetes executor, we had a way to execute notebooks reliably by running them in the same environment they were written in, because we were carefully maintaining the Docker images for both the Jupyter Hub and Airflow deployments. The next question was, How do we make authoring DAGs easy for anyone? We didn't want to stop anyone from scheduling their notebooks just because they weren't familiar with Airflow's Python API. So we came up with YAML DAG definitions, where any user could declare some DAG metadata using YAML and not care about writing a Python DAG file. Since most of the DAGs looked similar, we created Jinja templates for each type. Single notebook DAGs were the simplest, as they needed just one paper mill operator. And based on the DAG metadata a user provided, we would generate the final Python DAG file by rendering the Jinja template with the YAML values. But this still requires a user to first write the YAML and then build a DAG file, and then also learn Git in order to push all the files to the DAG's GitHub repo we maintained. And that's where GitHub and Jenkins come in. We cloned and automatically updated the DAG's GitHub repo using pod hooks every time someone launched their Jupyter Lab server. When a user wanted to schedule their notebook, they could just go into the clone directory and create a new notebook project using a CLI tool that we baked into the environment. They could then just write some DAG metadata, like their name in the scheduling information, and copy their notebook into the project and push it to GitHub with this simple command. This would open a pull request against the DAG's GitHub repo. The workflow looks like this. A PR is raised by adding the YAML in notebook. This triggers a Jenkins job to render the Python DAG file. The job pushes the rendered DAG file back onto the pull requests branch. And additionally, the job does some other things, like checking for missing fields in the YAML, validating existing fields, checking for syntax errors in code, formatting the code, and finally adding a comment to the pull request with the build status. Before the pull request could be merged into the main branch, we also required a review from someone else in the same team. And when no reviewer was available, one of the data engineers would review the PR and merge it. And after the pull request was merged, a deploy job would push the new DAG to the EFS volume that was mounted on all Airflow pods. And that's how we enabled everyone to schedule a notebook that they wrote very easily. Today, this workflow is used by every data analyst and scientist and a lot of people in non-data roles across both of our offices in National Capital Region and Bangalore. These are some types of workflows that people have built. Notebook ETLs that load data into tables in Redshift, a data warehouse which powers our Tableau dashboards. Notebooks to send reports to various people inside the organization if some condition on some table is not met. Notebooks to train machine learning models on new data every day and load predictions in a table that's used by a consumer-facing system. And also very complex notebook workflows where multiple notebooks run in parallel to calculate the stock of items in different warehouses, with one final notebook calling the API for a downstream system that sends relevant orders to replenish the warehouse stock for the next day or week. Let's go through some of our learnings from setting all of this up. Always pin dependencies in all of your requirement.txts and Docker files. Initially, we were using the latest tag on the data science Docker image, but this one time, after building all the images and updating the Jupyter Hub Kubernetes deployment, every user would see an error when they tried to launch a new pod. It took a long time for us to figure out that the new version of the image broke some old kube spawner behavior that we were depending on. Pinning dependencies also helped us move quickly when we had to migrate from our old Kubernetes cluster to a new one. We just installed the Helm chart with the same config values, pointed the domain name to a new IP, and no user felt that some migration had taken place, since for them it all worked exactly the same. You should actively monitor this whole system using Prometheus and Grafana. It can help you get relevant metrics to improve user experience and also help in resource planning. After we started monitoring the resource usage for our Jupyter Hub deployment, we found that we could fit the same number of users on half the nodes, which helped us reduce cost. This one time, a user accidentally deleted their notebook, which contained all the work they'd been doing for the past 1 week. Yes, they should have pushed it to GitHub. And no, we somehow didn't find it in notebook checkpoints. But we were able to find the notebook in the latest EFS DAG hub. Another time, an engineer accidentally reset the Airflow metadata database, on which the Airflow scheduler has a hard dependency. But we were able to quickly restore it from the latest RDS snapshot. You can also make some improvements on top of this setup. For new users, the graphical interface is much better than a CLI. New users shouldn't have to pay the command line tax and learn new tools like Git to work with data on the platform. Though Git is a powerful tool to learn, it shouldn't be forced upon anyone to do their work. A new project to check out in this space is Elira, which gives you this cool visual editor where you can drag and drop notebooks and build complex notebook pipelines. It also gives users a nice interface to review changes made to notebooks. And in a notebook-centric data platform, notebooks should become first-class citizens like tables, so that it's easier to discover them and build on past work. You can check out Amundsen to build a searchable catalog for your notebooks. I hope this was a nice intro to how you can use open source tools to build a notebook-centric data platform. And I hope you also learned about some problems that you can solve early in the process and some improvements that you can make. All of the docs related to this talk, like the Helm configs and the commands, will be available in this GitHub repo. Thank you for listening. If you're looking for a software/data engineer to join your team, or if you just want to chat about how awesome Jupyter notebooks are, you can reach out to me on Twitter at vortex_ape or using the contact information on my website. Lastly, I want to give a huge thank you to the JupyterCon team for everything they've done to bring this conference online. See you all next year.
My name is Will Sikorsky, and I lead the Kaggle competitions team at Google. We love Jupyter for its ability to move between code, data, and visualization. Over 2/3 of the code we write lives in a Jupyter notebook.
Hey, I'm Meg Risdahl, and I lead Kaggle's Notebooks team at Google. Kaggle's community of 5 million data scientists uses our Jupyter-based IDE to learn, participate in machine learning competitions, and explore public datasets.
I'm Carl Weinmeister, and I lead a team of data science advocates at Google. Jupyter Notebooks have been an indispensable tool to help our users learn to build ML solutions in the cloud.
Murega, Jetogo Wagwiwa Kariuki, Kuma Master Cohort, Nairobi, Kenya. Karibuni JupyterCon 2020.
Habari zenu, naitwa Mariam Haji kutoka Master Cohort. Karibuni JupyterCon 2020.
What impact does extreme weather have on oil production in the North Sea?
How is a 1 peso tax helping save an entire generation of children?
If 70% of everything we buy is delivered by truck, what happens to your grocery bill when there's a severe driver shortage?
How can bread scarcity spark a global political revolution?
Our planet is alive and interconnected, continually shifting, adapting, and growing.
Every event, big or small, results in other events.
At Bloomberg, you'll investigate, examine, and interpret these unique and seemingly unrelated connection points in real time.
The success of our business relies on people just like you.
Who can look into the future and create groundbreaking technology, research,
and expert insight to answer the world's most complex questions.
When we solve problems with a greater sense of purpose,
change begins.
Dots connect.
Society excels.
The world transforms when work has meaning. Your career thrives when you feel a deep connection to it.
That's why at Bloomberg, we work on purpose.
Ready to find yours?
Hi JupyterCon, this is Jan from PyData Südwest.
Guten Tag, this is Alex, and this is how Südwest looks like. And this is how you can find us.
Yes, exactly. So we are a region of highly interconnected cities, and we decided to join forces and host a multi-city meetup here in this area. And as you can see, we're not too far from the French border or the Swiss border, but actually it's really easy to get here from anywhere really. Even by train, it's quite easy.
Our PyData community is as any other PyData community, all about community and of course data and programming. Unfortunately, we couldn't get hold of everybody, but here are some members of our community who would like to say hello and introduce themselves.
Hi everyone, it's Christina. I'm one of the organizers and I'm from Mannheim.
Hey, this is Larissa. I'm a data scientist at Savanta from Heidelberg.
Hi everyone, this is Sia from Heidelberg.
Hey, this is Kiran. I'm a data scientist from Heidelberg.
Hi, I'm Matthias from Baden-Baden, new member from PyData Südwest.
Hi, I'm Kevin from Karlsruhe, currently in Austria.
Hi, I'm Uwe. I'm a data engineer and a PyData organizer from Karlsruhe.
Hi there, this is Ingo from Karlsruhe.
Hello, this is Xiatong. I'm a data analyst from Heidelberg.
So over the last 2 years, we actually hosted a bunch of really cool meetups in this area with topics ranging from Python for astronomy to building dashboards with Jupyter. And we're really proud to say that we had both local as well as international speakers as guests in Südwest.
So, if you are from our region and you are not a member yet, please come and join us. If you travel by, come and be our guest. You are always welcome. We would also like to thank the organizers of JupyterCon for organizing the conference and giving us the opportunity to present ourselves here. Viel Spaß!
Enjoy!
Enjoy JupyterCon!
Enjoy JupyterCon!
Enjoy JupyterCon!
Hello everyone, thanks for joining. Today we'll be talking about how we leverage Apache Airflow as an orchestration tool to build a distributed pipeline with Jupyter Notebook. Here's the agenda. Firstly, we will talk about the background on how we build notebook kernels as Docker images and then deploy them in a Kubernetes cluster. Then we will go over approaches to orchestrate notebook jobs as a pipeline. These includes notebook UI, Magics, and the REST API. These will be followed with a short demo. Then we will briefly talk about the architecture on how Airflow is deployed on Kubernetes and how we leverage Helm as a tool to help with deployment. Then we will close it up with the summary. My name is Wei Jun. I'm a software engineer in AI ML platform at PayPal. Join me is Karthik. He has over 12 years experience in building distributed system and applications.
Last year, our focus was primarily on containerizing Jupyter Notebooks app and implementing Kubernetes to modernize our existing notebooks infrastructure, which was incumbent to eliminate many of the manual processes involved in deploying and scaling our legacy monolithic multi-tenant notebook infrastructure. In this talk, we will present you a few architectural tidbits from our journey through this. Our old native setup involved centralizing notebooks using multiple Jupyter Hub services on a highly available notebook server grid platform, deployed on bare metal servers and used NAS as shared and decoupled storage layer. Our end user typically accessed notebook environment through a load balancer. A single Jupyter Hub can spin up multiple notebook servers, typically one per user, with shared CPU and memory resources. Now, with this setup, we encountered a few issues which galvanized our modernization effort. We often encountered resource contention, especially in terms of memory during peak hours, and paucity of a disk quota management required us to have additional housekeeping managing the disk space. Lack of GPU support was an impeding factor for data scientist group as it required them to switch to a different environment to use GPUs. Apart from those, we also had the operational challenges such as limited scalability, maintenance overhead, and feature limitations like no support for remote kernels. Architecturally, we made 3 key changes to circumvent the issues. First, as you can see, we containerized all our notebook processes, Jupyter Hub, notebook servers, and remote kernels, which enabled us to scale up and down with zero manual effort. One of the magics of Kubernetes. Now, notebook servers are launched remotely by Jupyter Hub instead of local. Second, we introduced enterprise gateway servers, which enabled us to launch kernels in different servers, thereby distributing resource utilization across available compute resources and help us easy resource management to shared compute cluster for large number of users. Third, the PVCs. Persistent volume claim, we further virtualized and abstracted the storage, thus providing more control over the storage requirements and access per user. Jupyter Hub Services is launched as pods in Kubernetes. When a user tries to launch a notebook server, Jupyter Hub authenticates a user and launches a notebook server in the namespaces that they are having permission with. User is provided with multiple options depending on the role. Once a notebook server is launched, it will connect to the enterprise gateway to fetch the kernels. Each kernel will be running as a pod with allocated resources attached to the pod.
Now let's talk about the different ways of scheduling notebook jobs. The easiest way is to schedule a job via notebook UI. We can specify the running interval, start time, end time, and email notification. Click on the schedule button. A DAG file will be generated in the backend, and the Airflow running in the Kubernetes cluster will pick it up and run. And after the job is completed, you will be able to see the key metrics in the notebook UI itself. Now, the first approach seems very straightforward, but it do come with a restriction. That is, we cannot schedule multiple notebooks at the same time. That's why we provide the second approach, which is to schedule a job via notebook magics. We are passing a JSON configuration to the schedule magic. -A specifies a type of action, which is to create a new DAG. You can also get the status of the job, update a job, and delete a job. To meet our data scientists' requirements to incorporate a scheduling feature, we provide a third approach, which is to schedule the notebook via REST API. The user would have to define a configuration file that includes the specification for the job, the tasks, and the dependencies between the tasks. And the user will pass the configuration to the REST API, and a corresponding DAG file will be generated and stored in a PVC. Now let's jump into the demo. Here is an example of using TensorFlow 2 kernel to train a convolutional neural network. To schedule this notebook, first I have to right-click the notebook and click on Schedule button. Here you can specify the interval, the start time, end time. But for testing purpose, let me run it immediately by click on the Run Mouse button and skip the email and click on Schedule. So you will see the notebook has been successfully scheduled. We can check the execution status of the job via Schedule Jobs tab here. Click on that. It will show that the job has been executed. And when we go back to the notebook, you will see that the train has been completed, and it prints out the training and the validation accuracy. So now let's see an example of scheduling multiple tasks in the same job via schedule magic. So you can see here I'm passing a dictionary to the magic. We defined the job specification, each tasks, and the task need not be a specific notebook task. Here I'm only writing some random text to the file, which is stored in a PVC. We have 4 different tasks, and here we define the dependencies between these tasks. Now let me execute this one, and we are getting a 200 response. Now we can see the status of the job by using this command. This will get the state of the job. We can see it is running, and we can also delete the job. We'll see it has removed the records in metadata DB. So now let's see the third approach of scheduling a notebook pipeline. You can see here I defined a task to run 3 consecutive tasks. These tasks are running in different nodes. The first and the third are running in CPU node, and the second is running in GPU node. So now let me go to the terminal and run the curl command to pass this JSON configuration to the REST API, and hit enter. And let's go to the Airflow UI. And here you will see that these 3 tasks has been scheduled in a pipeline. Okay, so now after a few minutes of waiting, we can see the job has been executed successfully. Now let's go back to the notebook and open up the third task. Let's go down and see it has generated a poem starting from my name based on the recurrent neural network model we trained on top of the Sonnet.
This is a high-level architecture of implementing and orchestrating Airflow using Kubernetes. Let me start from the top left. Airflow has 2 main components, scheduler and worker. Each of these components is deployed as a pod in Kubernetes. When the user schedules a notebook, the DAG is written to the PVC that is attached to the scheduler pod. The scheduler pod launches the worker pods for each task. The task is executed by the Kubernetes operator that reads the notebook metadata and fetches the information about the image, type of compute resources needed to execute the task. Once the execution is completed, the user gets notified about the status of the job.
So in paper, notebook is deployed in different environments with different configurations. And that's how Helm comes into picture. We first abstract out the differences in configurations and store them as a YAML file. When we do the actual deployment, this YAML file will be passed to Helm and further be referenced by the config map. So in summary, using Airflow with Kubernetes executor, we were able to achieve a high level of elasticity. The number of concurrent tasks are now no longer restricted by the machine capacity. It can be easily scaled up and down based on the actual workload. We can separate the duties of the engineers in the same team who are working on different parts of the pipeline. It can also be easily maintained because the tasks using different environments in the same pipeline can be isolated with the task level pod configuration. We can also allocate the resources efficiently by separating different stages of the ML pipeline. That will conclude our demo. Thank you so much for watching.
My name is Will Sikorsky, and I lead the Kaggle competitions team at Google. We love Jupyter for its ability to move between code, data, and visualization. Over 2/3 of the code we write lives in a Jupyter notebook.
Hey, I'm Meg Risdahl, and I lead Kaggle's Notebooks team at Google. Kaggle's community of 5 million data scientists uses our Jupyter-based IDE to learn, participate in machine learning competitions.
Hello everyone, and welcome. My name is Tim Payne. I'm a developer at JP Morgan in New York City, and today I want to talk to you about production notebooks. So just as an overview of today's talk, I'm going to start with a little background on JP Morgan and one of its software platforms called Athena, as well as details of Athena's Jupyter deployment. Then I'm going to jump into how do we leverage Jupyter, some of the infrastructure that we use to support its deployment, some development methodologies we've built around it, as well as some notebook-derived applications and tools that we've built. Finally, I'm going to get into the meat of the talk, which is really software lifecycle and software libraries we've built to support safe notebook use in production. And I'm going to clarify what I mean by notebook use and what I mean by production at a later point in this talk. So just for background, JP Morgan Chase is one of the world's largest banks. JP Morgan is the investment banking side, Chase is the commercial and consumer banking side. We have over 40,000 technology employees globally. Our annual technology budget is, around $10 billion. So it's a massive technology organization with many different teams working on many different problems. Within JP Morgan, the investment bank side, one of the largest software platforms is called Athena. So it is a Python-based platform. There are around 2,000 developers working either on Athena itself or within the Athena ecosystem. There's around 40 million lines of code in the code base, organized as a mono repo. So it's a massive platform We have 1,000 plus open source packages, Python libraries, C++ libraries, Java libraries, things like that. And we have hundreds to thousands of production code releases per day, people pushing code to production. So it's a massive and extremely dynamic platform. If you're interested in any of the details of the platform itself, that's not the topic of today's talk, but there's a great talk with slides from PyData 2017 in New York City called Managing Python at Scale Without Breaking the Bank. And that dives into a little bit of the tools and SDLC and infrastructure and basically how do we keep this platform running while still enabling it to be dynamic. So feel free to look at that if you're interested more on the platform itself. For me, my team is called Athena Research. It's within the larger Athena team, and we're responsible for our Jupyter deployment, as well as lots of analytics applications, sort of AI and machine learning tools and libraries. Really anything that's open source and up and coming, we'll investigate, develop, integrate, deploy, do whatever we need to do to leverage it. And for our Jupyter deployment, our primary platform is a hosted instance that serves thousands of daily users globally. Most of them are business users or quantitative research, basically people not in a development role, which brings with it all kinds of interesting challenges. If you're not familiar with the internal structure of an investment bank, the different businesses here doesn't mean too much to you, but suffice it to say, we have a lot of people coming from a lot of different backgrounds, working on a bunch of different business problems all around the world. So how do we use Jupyter? We run Jupyter in production with 3 target deployments. So the first is the obvious one. It's basically Jupyter itself. We have a Jupyter Hub style platform. It's a single deployment for around 1,500 users. We make the libraries available for them to run locally, but generally people prefer the convenience of just opening a tab on their browser and getting a new Jupyter instance running on some cloud machine somewhere. The second one is static reports, so notebook-derived reports leveraging NB-Convert and Papermill to create PDF or HTML or email reports. And we're running hundreds of those daily, and that sort of the number of reports that we're running is increasing every single day. We also run live applications based off of notebooks using the popular Voila library. We have around 50 of them currently in production and over 100 in development. So Athena brings with it a lot of tools and infrastructure to help us in our Jupyter deployment, and 2 that we rely on very heavily are a scheduler that supports both batch jobs and high availability jobs. For the batch jobs, we might leverage those to run our reports on some predefined interval or at some daily time. For the high availability jobs, we use that with Voila to make sure that the Voila instances are running in all of the regions on all of the machines that you expect them to be running on. The second thing that we leverage is a distributed replicating object store. And this is used for both data and code. It allows you to look at different slices. So I might be able to look at like a development slice with a production layer underneath. Basically makes it easy to collaborate and to work on different projects. And so the distributed and replicating nature of Hydra makes it very nice. If you save a notebook in New York, it's almost immediately available in Tokyo. When we run deployments of either Voila applications or these reports, everybody can be looking at the same code or the same data globally, no matter where or when the code runs. So I'll take the time now to clarify, what do I mean by production? So for this talk, instead of focusing on the Jupyter Hub deployment, because that's, the state of the art is open source and the details of how we actually do that are not particularly interesting. Most of those things are sort of well explored in the Binder or, Jupyter Hub projects. I'm going to focus on the production report side of things. And when we say production, we really mean that me as an individual business user, an individual developer writing a notebook, I come to a certain point where I want to share that notebook with other people. And generally, when we're talking about production, we mean that you want to share that notebook with non-technical users or people looking at it outside of a notebook interface. The most common question that we get when it comes to, when it comes time to deploy a notebook is, can I just hide the code and see the outputs? Also alongside, production notebooks, that generally means running the notebook in any type of automated fashion. So it might not mean generating a report or running a Voila application, but it might mean making sure that that notebook still works with the code changes or library changes underneath. So obviously, we want to have a production notebook. Implicit in deploying a notebook to production is that the notebook is stable, that it's testable in some form, it's deployable in some way, and that it's extensible. Alongside these things, we want to when we're talking about production notebooks, we want to encourage best practices. So we want to avoid a lot of the pitfalls and anti-patterns highlighted in the popular talk from last JupyterCon called "I Don't Like Notebooks." So when we're talking about production notebooks, we mean these are no longer scratch pads for quickly iterating or experimenting. We're really using these tools to bring some libraries together with some data and present it all together with text and markdown. And for us, we generally encourage that, you get to a certain point in the life cycle of a notebook where the actual libraries that you're writing should be pushed down into our more full-featured IDE. One other thing, when we're talking about production notebooks, we generally mean linearly executed notebooks. And this is one thing that's highlighted, very extensively in the I Don't Like Notebooks talk. When you're talking about running a notebook in an automated fashion, you generally mean it's executed top to bottom one time. And this is true of both our static reports as well as Voila applications. So let's get into the real content of the talk, which is the software development lifecycle and software libraries that we've written to deploy production notebooks. All right, so we're going to again be focusing on the report side and the Voila applications side. The real question, the real problem that we're trying to solve is, with all of these applications and these two deployments, how do we stop them from breaking in a code base that might update hundreds of times per day with open source libraries constantly changing underneath them? And the solution that we've come up with under active development, of course, is called NB cell tests. So NB cell tests is a library that we basically have written to support linting and testing notebooks. I want to take a moment just to look at some prior art because I think it's important to highlight these things, but also because we use them in our library. An important one is called NBVal. It's predominantly targeting reproducible notebooks for scientific research, and it compares the stored outputs of a notebook with the outputs generated when you rerun the notebook. It integrates very nicely with PyTest. For us, we couldn't use this library off the shelf because we have a couple of problems unique to our deployment. One, we can't always store the outputs. So if there's sensitive data in the outputs, or charts or anything like that, we might want to purge that prior to saving. So we might not have that available to us when it comes time to run NBVal. Secondly, almost everything we do is temporal in nature. Prices today and prices tomorrow are going to vary. So it's almost never the case that we expect the outputs to match. Right? We expect those to be changing every day. And we want a library that can where we can structure tests to take that into account, kind of simulate what are today's data supposed to be, and we can test against that. So another prior art, though it's really concurrent art because it's also under active development. All of these are under active development. I think NBVal was probably the first one. Is called Testbook. So Testbook is a very promising library which lets you kind of extract and unit test cells, which is a very similar type of functionality that we want. We'll likely integrate with this library in the very near future, but for now, we really want to be able to do invasive mocking within the cells of our notebook to really make sure that we're fully unit testing what's getting done. And it doesn't quite allow for that yet, though it looks very promising. So NB cell test brings with it two main features. The first is linting, and we're really targeting notebook structural lints. And I'll highlight what this means in just a second. We also allow for cell-by-cell testing, so cell-by-cell unit testing. So taking into account, the pitfalls of developing in a notebook, this library encourages or enforces best practices through these structural lints. And it enforces this idea of, single run top to bottom execution through these lints. These lints are designed to basically enforce that if you're writing too much code in a notebook, if you're trying to build libraries in a notebook, that this is a bit of an anti-pattern and it introduces a lot of danger into the notebook, especially in such a dynamic platform. So we want to prevent it if possible. So we can lint our notebooks for things like the number of lines in a cell, the number of cells in the notebook, how many class definitions or function definitions are you doing in a notebook, and these are sort of high signs that you might be doing too much library development in the notebook itself, and that stuff should be pushed maybe into a Python module where our tooling is more extensive around that. We can also lint for things like the kernel that you're using, any magics that you're using that may or may not be safe outside of a notebook context. So in something like a report or in something like a Voila application. And of course, we allow you to kind of export your notebook to a Python module and run a traditional Python linter on it. Cumulative cell testing, which is the other key feature of NB cell tests, lets you write tests around your cells. So for each cell, we generate a test that builds on the previous cells in the notebook. And it's structured in such a way that it lets you sort of run a pre-cell hook and post-cell hook. So let's just take a look at a little bit of sample code to show this. So in this sample code, I've got like some module, let's say, that I'm using. I can patch using just a mock, some function call that I'm doing. Then we allow for a special cell magic, which is this %cell, which basically means insert the contents of the cell at this location. Right, so this lets us do some stuff before we execute the cell, do some mocking. Maybe we're doing a database call, or maybe we have some sample data that we're gonna inject into our, we're gonna mock something to return some sample data. We can then run our cell to kind of pull that stuff in. And then afterwards, we can do some assertions to validate that exactly what that cell is supposed to do, executed as expected against the mocked out data that we've injected. And these cells stack up as you execute the notebook. So, future cells build off of the results of previous cells. So it lets you really unit test each individual cell to a really deep degree, as well as ensure that your notebook's total functionality is what you expect. These linting and testing, these two major functionality, we can then integrate into our IDE, which we have. All notebooks that are going to go to production, so you want to deploy a production scheduled job of some static report, we obviously enforce that you pass some set of lint rules. For these structural things, we might enforce no more than 10 cells in your notebook. And any tests that you write, we want to make sure that those pass. In addition to having to pass before you go to production, as libraries change, as your dependent code modules change, we continually run those tests and we'll send you alerts if things fail. Last little thing I want to highlight, we leverage a lot of state-of-the-art open source here. Notebooks, when they're presented under VC, will just show you diffs with Jupyter, so make it a little bit easier for you to look through them. So I want to take a moment to just take a look at NB cell tests in action, and we're going to use a front end that I've built for it. For Jupyter Lab, a Jupyter Lab extension for it. And I'm just going to write a little bit of dummy code. I'm going to import pandas. I'm going to, make a data frame, show the grid. And then what I'm going to do is I'm going to write a cell test for that little bit of code. So I'll mock out one of the calls with some sample data. Inject my cell in the cell test, and then validate that the data is what I expect it to be. And the idea here is if that was a database call or some temporal data, we can kind of validate that exactly what our cells are doing is correct. Finally, I'm going to just show the linter in action, and I'm going to tweak some of the rules, the lint rules for my notebook, and run them. So let's just get into it. So I'm just going to create a new notebook, as I said, where I just create a pandas data frame, and I'm going to use one of their utility libraries at pandas.util.testing.get time series data. It just returns some dummy time series data. So here I construct the data frame, and let's just take a look at it. All right, just a normal data frame, couple of columns. And I'll just create a seaborne heat map here just for fun off the column correlations. It's all randomly generated data, nothing super interesting. So if I pop over to the Notebook Tools tab within Jupyter Lab, we'll see the cell tests interface. So markdown cells don't have testing yet. We don't know if that's something we want to do in the future. So let's just focus on a code cell for now. I'm gonna mock out this pandas util testing get time series data, and I'm gonna have it just return some dummy data. So I'm gonna patch it using the mock library, have that return some of my dummy data, just, a list of dictionaries, whatever, some different data. Then I'm gonna use that special cell magic to inject my cell. And finally, I'll assert that the data contained in the data frame is equal to the dummy data that I've done. All right, let me save that. All right, so just a little test to show that we can do this mocking in this kind of invasive mocking. When I run these tests, it'll run them under PyTest in that cumulative fashion. So we'll see 4 cell tests running, everything passes as expected, great. And we can obviously run these things offline. Once we've written the tests for a notebook and kind of saved them, keeping the whole notebook asset together, the tests and the code alongside each other, means we don't have to worry about them getting disconnected. We can then plug this into, as I said, the IDE can run tests, the sort of SDLC commit push process can have this hooked in, and we can run them on some scheduled fashion so that code changes, library changes, we can check at a very granular level if these affect your notebook. So the last thing we'll do is look at some of these structural lints. So these are available from the same tools menu. So let's just quick put in a new lint saying that we're limiting the total number of cells in our notebook, and let me limit it to 3 for now. Then I'll pop back over to the command palette and run my linter. So obviously this fails, and we can integrate this with our IDE or with VC like anything else. And it fails because I had 4 cells in this notebook. So let me just quick tweak it to 4, rerun the lint, and we'll see that everything passed. All right, so just like our tests, we can hook this into our IDE, we can hook this into this ongoing SDLC process. And with these lint rules, one thing that we can do is, obviously they're exposed in a notebook for you as an individual, just as an end user, to be able to kind of play with them. But in our enterprise deployment, we make these things sort of centrally overrided, so we can enforce that across the whole organization. Nobody's defining too many classes or too many functions in the notebook. And this is all designed around enforcing those best practices. Linearly executed notebooks, pushing code wherever possible into modules where we have greater developer tools around them to kind of, we can build, in many cases, better tests around the Python libraries than we can around the notebook themselves. We can enforce different linting rules, some better linting rules around those. All of these structural lints are designed to encourage, or in some cases, enforce that. So that was a brief overview of this NB cell test library. It's available on GitHub under the JP Morgan Chase account. It's under active development. We're still working on it. There's a lot of work to do with the front end, hooking that in. We also look to kind of partner with some of these other open source libraries so that we're not doing the same thing over and over again. So please do check it out. We're leveraging it right now in production for development. Take a look. So I'm just going to highlight a couple of other libraries and other things that we've built or other people have built that help us run these static reports and these Voila applications more smoothly. These are not necessarily things that we've developed, but they're things that we find help us ensure the sort of stability and general functionality of these deployments. So one thing that we leverage a lot is a custom tweak to Voila, which lets us run things and inject things into the notebook. So we can basically inspect the tornado request. If you don't know how Voila works, it's basically a sort of sharded single user notebook as web app. So we can basically look at the web request, do some authentication, user impersonation, logging. We do a lot of logging across all of these deployments just to kind of look for things going wrong, look for weird problems, and be able to kind of figure them out and fix them as quick as possible. We can also do some production validation and some UX, some UI stuff. So let's take a couple of looks at it. This is currently a PR on the Voila repo. So we can do some cool things like, and we leverage templates as well. We've got this kind of launching indicator. We can do things where the notebook has some functionality to detect, am I running in a production environment? Am I running in a non-production environment? Library versions, I can send emails, things like that. We can kind of inject that ability. We can also do with templates and with the pre-launch hook, some disconnect alerts, some things like that. So it's a very helpful library, good for end users who aren't going to want to see like a stack trace. Another JP Morgan library that we've written is called Jupyter Lab Templates, and it basically lets you take a notebook and use it as a template for other notebooks. And it's good for sharing some boilerplate, again, encouraging some of these good patterns and best practices. You can save templates for your whole team. And that's available on GitHub under the JP Morgan Chase account. One thing that we do a lot is we've wrapped some of the default Python kernels. So with some slight modifications, you can do resource limits on top of IPy kernel. So here's a very short example. In something like a Voila deployment, maybe you've got a machine that you're running it on, maybe there's other jobs running on that machine. You want to be able to restrict resource allocation. So here I just throw in some CPU limits and some memory limits, and then I defer to the IPy kernel instance. So it makes it very easy to kind of control your deployment. And we leverage this extensively because all machines always have more people wanting to work on them than there is CPU power. It's also useful for collecting stats and injecting logging, and so that original stats page that I showed earlier on in the talk was powered by some of these injections that we do. P2P copying in Jupyter Lab is another thing that we do that's very helpful. It's often useful to copy from person to person. Maybe you don't want to deploy a Voila application just to share a notebook between two people. This kind of helps us know when not to deploy a notebook. And with that distributed object database underneath, it's very easy to copy from the slice that I'm looking at to the slice that you're looking at, or for us to both look at the slice underneath. And we just have a little lab extension that lets us copy these things around. We can copy it from one slice of Hydra to another slice of Hydra. And finally, this isn't something that we use because for free, Hydra gives us a log of every save of every notebook. But just to get some of that same functionality without the deployment of Hydra, I've written this Jupyter Lab auto version library. And basically, it just transparently commits every save of a notebook to a backing storage mechanism and lets you revert through time. So that's also on GitHub. It gives us some of the same functionality of Hydra, but for non-proprietary, non-Athena users. So that's the talk. My GitHub is Tim K. Payne. The main library here, this NB-cell test library, is available under our JP Morgan Chase GitHub account. I encourage everyone to take a look, file bug reports if you can, use it. And for other people interested or currently deploying Jupyter at scale in enterprise, take a look, see if it integrates into your SDLC practices. And as always, let me know if you're interested in collaboration. Thank you everybody for listening and have a great day.